Hi, I'm Dahlia.
And I'm Josh.
Welcome to the CHEM111 laboratory video series. Today we will be doing experiment 1, basic laboratory techniques.
Before we get started, let's do a safety check. Before every lab in CHEM111, you should always have on closed-toed shoes, long pants, your lab coat. In this lab, gloves are optional, and then finally we need glasses. Let's get started.
Today in the lab, we are going to learn how to use a balance and learn how to pipette, as well as perform calculations of volumes and densities, and how to perform a simple air analysis. Let's think big picture. In today's lab, there's two main parts: calibrate a 10 ml pipette and determine the density of a salt solution. Why do we calibrate the pipette? We do it because it's not exactly 10.00 milliliters. And in order to do so, we determine the weight of the 10 mLs of water dispensed from the pipette. We use the density of water to convert the weight to the actual volume dispensed by the pipette, and we repeat this 3 times to get an average. To determine the density of the salt solution, you're first going to determine the weight of the 10 mL of salt solution dispensed from the pipette. Then you're going to use a calibrated pipette volume from the first part to determine the density. Repeat this 3 times, and finally you're going to perform the air analysis for each part with an average and standard deviation.
The first step in this lab is to obtain about 40 milliliters of water. You don't need to measure it out, just fill your beaker up about halfway. Then allow it to come to room temperature for about 5 minutes. After 5 minutes, take the temperature and write it down in your lab notebook. While waiting for your water to come to room temperature, get your dry Erlenmeyer flask and obtain its weight. When using the scale, always record 3 places past the decimal. Remember to hit the tare button with nothing on the scale. Don't drop anything on the scale. Remember to close the glass before taking the mass, and remember just to take care of the scale in general. Record the mass of your empty Erlenmeyer in your lab notebook. We need this mass in order to subtract it from the sample of water.
Remember to use common sense in a chemistry lab. For example, if the mass of your Erlenmeyer flask is only 1 gram, then something is probably wrong. Tip: remember to always tare the scale before taking a mass. The very first step when using any pipette is conditioning, which is essentially rinse the pipette first to make sure it's clean. To condition your pipette, place the pointed end into the water and compress or squeeze your disconnected pipette bulb. Then place the bulb on top of the pipette and finally decompress or release the bulb, allowing it to pull up liquid into the pipette. Just fill the pipette about halfway, then set your bulb down. Take the pipette out of the water and tilt it onto its side. Rotate the pipette around just to rinse all sides of the pipette, then simply allow the water to drain into a waste beaker or down the sink. Repeat the conditioning process at least 3 times.
You're finally ready to pipette and weigh out that 10 milliliter sample of water. Correct use of the pipette begins just like conditioning. Place the pointed end in the water, squeeze your disconnected pipette bulb, place the bulb on top of the pipette, and then release to draw up the water. You may need to disconnect the bulb, squeeze, reconnect, and then release several times in order to pull up enough water into the pipette. Watch carefully as you near the top of the pipette. Always draw up liquid past the fill line and then quickly replace the bulb with your finger on top of the pipette. Then bring the TD line or to deliver line right to your eye level and carefully roll your finger so that the water level falls down slowly. Once the bottom of the meniscus rests right at the line, keep your finger tight on the top of the pipette and bring the pointed end to the inner wall of your pre-weighed Erlenmeyer. Then remove your finger from the top of the pipette to allow the water to drain down the side. Keep the pointed end touching the inner wall of the flask, and once all of the liquid is drained, there will always be a tiny bit left in the end of the pipette tip. Do not force out this tiny bit of liquid. The pipette is designed to account for the liquid that remains.
After carefully and correctly delivering 10 mL of water to your Erlenmeyer, obtain the new weight of your Erlenmeyer. Don't forget to tare the balance before use, and of course, write down the new weight in your notebook. Calculate the weight of the 10 mL of water dispensed by your pipette, then use the temperature of your water to find the accurate density of the water on table 1.1 in your lab manual. Finally, calculate the actual amount of water delivered by your pipette. It should definitely be around 10 mL but it will very unlikely be exactly 10.00 mils.
After obtaining the weight for trial 1, you need to collect the data for 2 more trials and obtain an average. Simply use the final weight for trial 1 as your new initial weight for trial 2. Pipette another 10 milliliters of water and then weigh again for your trial 2 final weight. Do this once more for trial 3. After you've calibrated your pipette, you can then determine the density of the salt solution. In a new beaker, obtain about 40 milliliters of the salt solution found in the hood. Again, you don't need to measure out this amount. Just fill your beaker up about halfway.
Don't forget to recondition your pipette, this time using the salt solution instead of water. Be sure to rinse all sides of the pipette thoroughly with the salt solution. Then simply perform the same tasks as before. Obtain an initial weight of your Erlenmeyer, pipette 10 ml of the salt solution into the Erlenmeyer, and then obtain a final weight. Calculate the weight of the salt solution dispensed by your pipette. Then recall that in order to determine the density of the salt solution, all you need now is the volume. Thus, using the actual volume dispensed by your pipette, calculate the density of the salt solution. Obtain 3 trials of determining this density, and you're done.
Two thumbs up.